Hello, everyone. Welcome. We're excited to talk to you about multi-region serverless applications today. I am Magnus Björkman. I'm an AWS Solutions Architect, and I'm here with...
Hey guys, I'm Stefano. I'm a Specialist Solutions Architect with AWS, and I focus on all of our serverless offerings. So API Gateway, Lambda, Cognito, Step Functions, etc.
Thank you. Right, so in this session, we're going to talk about what you need to consider when you're going multi-region with serverless. And we're going to do it in the context of a real-world serverless application. We will be looking at why would an owner actually want to go multi-region, what are some of the patterns that the owner can use in the application. We have broken down the application into microservices, and we're looking at these microservices one at a time. And then we'll finish off with a little bit on developer tools, deployments, and monitoring and stuff like that. All right, so let's first look at the example application. So we have this made-up company. We call it Food for Thought, that allows customers to order food and get it delivered. So they obviously need to be able to browse restaurants, look at the menu, see what they like, create an order, submit the order, and then get the food delivered. So this company is doing great business across both North America and Europe, and they want to have the customer have a great experience no matter where they're located. So low latency, and the application should be able to keep up with demand. Customers don't really randomly order food throughout the day, but instead they are concentrating on the demand during meal times in whatever time zone they happen to be in. So this creates two critical requirements for them. One is that they have to be able to handle this highly variable load throughout the day. And also, since most of the ordering is happening during the lunch and the dinner times, the application absolutely have to be available during those times, since that's when the bulk of the revenue will happen. So this type of use case is, there's a great fit for serverless, right? Especially the two last things I mentioned. If you look at the gray box, they're kind of a direct match to that, right? So the ability to scale with demand, and the availability and the fault tolerance built in automatically. Of course, also happy with not having to have that overhead for provisioning any servers or manage them, and never having to pay for idle. So with these great benefits, why would they ever want to go multi-region? What would be the reasons to do that? So, well, first of all, if we have a user in Europe and they would have to go all the way to North America to get to the application, there would be a latency hit. There's no way around it, right? So we want to be able to place the application in a region that's close to the customer, so they would get that improved latency and performance. Also, that criticality of having the application available during meal times makes us want to architect the application in a way that had that increased fault tolerance that's more or less possible to do just within one region. Also, if you're dealing with personal information, we also might have to adhere to some strict laws around that as well. So some of the information that is created in a particular country might have to stay in that country. So those are some of the main reasons we're looking at here, why we would want to go multi-region. So now Stefano will look a little bit in more details on the considerations we have to do.
Thank you. So Magnus and I didn't just put together a deck and came here to present it. We actually sat down and designed this application and thought through all the possible use cases and where it was going to go wrong and how. And it turns out that as you decide to go multi-region, there's a lot of factors to it. It's not a decision that the technology team take on by itself. It's likely, what's likely to happen, and it will have happened to you, I'm sure, is that a business user comes along and says, this application must be up at all times. We need absolute fault tolerance at any time. And with that, inevitably, there will be compromises. The first thing that helps is if your application is actually designed to be separated into microservices. It's a lot easier to make an individual small microservice span multiple regions rather than take a monolith and try to make it work automagically across the regions. Our sample application, Food for Thought, is divided in 3 separate microservices, 2.5 really. The first one is the catalog service. This is what our end users, our customers use to browse the list of restaurants and look at their menu. We also have an administration service to this that we ourselves use to edit restaurants, add new ones, change the menu, and our partners, the restaurant themselves, can also go and update their details. And then we have the last service, the ordering service, which is really the core of our business. So as Magnus and I were going through the design and making the decision of what should be multi-region and how, we came up with a little diagram, with a little decision flow for ourselves. The first thing that we ask ourselves is this service we're talking about core to our business? Does it matter? And the fact is that regional outages are extremely unlikely. And if they were to happen, they are short-lived. And so a classic example of this would be, I am Food for Thought, I'm running my business. I have a BI service, a service that collects order information and customer information and shoves it in the database somewhere so that then my business users can come and analyze the data. It's a really nice service, but it's something we can live without for a couple of hours. It doesn't matter. So that's our first decision gone out of that chart. We don't need to go multi-region for this service. And once you move further down in the chart, then the question becomes data processing. And how many of you have tried to set up a database with a master-master storage that keeps consistency? You're brave for admitting it. Like, it's extremely hard. And so there's another trade-off we can make there. Do we need to have this master-master setup, or can we have just a master replica in the second region? We only care about reading data. As we go through, we'll talk about each service individually, and we'll tell you how we've made the decision and how we designed it. The other consideration that might not matter to you, but it will matter to your business user, is how much will this cost us? In fact, this argument is the best one to make the business users go away as they try to convince you to make it incredibly fault-tolerant. I have some good news here, which is services like API Gateway and Lambda only charge you for when your code actually runs. So your costs are tied to the amount of business you do. And no matter how many regions you run in, you have a fixed amount of customers that place a fixed amount of orders. So your cost is going to be the same, even if you're running multiple regions. Storage, slightly different story. It may increase your cost, and that's why it's important to have that conversation. How and what are we going to replicate? Trying to replicate the content of a DynamoDB in real time so that they're writable everywhere is going to be a lot more expensive than just being selective and perhaps just caching somewhere else in the second region. And last consideration is data transfer. Once again, this is tied, just like the serverless offerings, is tied to the amount of business you do. It's not going to change to the other region, but I just want to remind you to go and check the pricing page, because different regions have different egress costs. And this will figure in your bill, so you want to keep them in mind. Another thing that changes as you go multi-region is that your application becomes quite a bit more complex in terms of the code itself, and quite a bit more complex to operate. Suddenly, you're spreading operation across time zones, and you're having alarms from different regions. It's extremely important to make all of these processes automated, or as automated as possible. And how are you going to look at the logs when you've lost a region and you can't go there to figure out what happened? All of these are pretty important consideration. And finally, data sovereignty. Seems pretty easy when you think about it. Sure, I'm going to set up a user pool in the US and one in Germany, and German customers will register in Germany. What happens if a German customer registers from Germany Your Route 53 will direct them to the Frankfurt region. They will create their account there, but then they travel to the US and they try to update their account. Route 53 will naturally send them to the US region, where their account doesn't exist, or even if it did, you don't want to store PII data for them. So there's a lot of edge cases there that we'll talk you through. Keep them in mind as we go. And now let's hand over to Magnus, who's going to talk about the first services.
Yes, thank you. So let's look at the browsing and updating catalog use cases and the microservices that goes along with that. So do a quick review here of these two services, right? So for the browsing one, that would allow them to browse the restaurants and the menus, and that's actually a critical step because that's something that they do as part of getting the order in that leads to the revenue. So this is part of the revenue flow. Looking at the update catalog one, though, that's less critical. People can still browse and make orders and submit orders without having some late-breaking news, some late-breaking changes to the catalog. So that one we deem less critical. For the consistency, we can have the same reasoning. We're fine that we eventually reads. The updates are not as critical here, and we don't have any dependencies for this. So if we go back to the tree that Stefano introduced, looking at the browsing catalog use case. So yes, this is definitely critical. So we make the decision here, we're going to put this in 2 different regions. And we will use the DNS routing to route them to the closest one based on latency. This is a read-only use case. So yes, there will be some data flowing into this, but for this use case, this is read-only. And how are we getting those updates? So there's kind of two different paths here. One is a scheduled replication, but in this case, we think that's a little bit too much latency. That's kind of part of the judgment we need to make here. So instead, we go on with the near real-time replication, eventual consistency from a master copy. If we take the same tree and look at the updating catalog use case, we stop much earlier. So here, we're really stopping already at that first step. We can constrain this into one region. We only need to deal with one table that we're updating. This is a fairly important realization because now we can start simplifying a lot. And we can kind of remove that architecture complexity that we required. Like if we set this up and decided this was a critical service, we very likely would need to put some sort of master-master replication into place. So let's look at the architecture for the browsing catalog one first. So this is fairly straightforward. In the back there to the right, we have our Amazon DynamoDB tables. Those are accessed from our business logic within our AWS Lambda functions. That is exposed through a REST API using the Amazon API gateway. Our mobile client is accessing those APIs over the public internet and then leveraging Amazon Route 53 to do that routing to the right region. And in the example we're showing here, we're using US East 1 and US West 2 as the 2 regions to kind of showcase this. So some highlights here. So the API that we're setting up, the multi-region API we're setting up, is an active-active. So it's taking traffic at the same time. And the client will connect to the one closest to them. So we're deploying the exact same stack in both regions. This is the read-only use case, but and we can constrain ourselves to then just read the tables from the local region. One optional thing here that might work well in this particular case is that if our catalog is fairly static, we can do some caching on this API as well by putting CloudFront in front of it. So the first thing I want to dig a little bit closer into is the API active-active setup. So this is something that's now possible because of a release that Amazon API Gateway did a few weeks ago now, where it introduced a new concept of endpoint types. So the edge optimized one is the one that was there before, where CloudFront is used to bring the endpoint close to the customer. The new one, regional one, will instead put that endpoint into a region itself. And one thing that allows, that's great for this, is that now we can have duplicate. We can have duplicate APIs and duplicate endpoints. And the key thing for this applies also to the custom domain names. So let's say for our example here, we put in api.foodforthought.com. We could have that same host name and the same custom domain name in 2 different regions. So a big change as part of this is that custom domain names used to be unique on a global level, and now they're unique at a regional level. So let's look at a diagram of how this might look like. So when we create this API, we have these API endpoints created. We see one in US 1, we see one in US 2. And these are the ones that will be created automatically by the API gateway. You can't really customize them. They will have a domain name that's auto-generated for you. So in front of that, we'll put the custom domain name that we'll have associated with our api.foodforthought.com. And we'll use that in combination with Amazon Route 53 to start getting this multi-region set up. So we will take the custom domain name identifier. We'll start creating records in Amazon Route 53. We'll create alias and CNAME records, one for each region. And that now allows us to use all the capabilities of Amazon Route 53 that we're used to when it comes to some of the other services we have. So we can do routing based on latency, geolocation, waiting, all of those ones. And we can also do failover. So that's the key to make all this active setup work. One thing we still need to do, though, to really make the failover work is we do need to implement health checks. So there's health checks in Route 53. We need to provide paths for each endpoint that the health checks can call to see if things are really doing well. And we recommend to do specific paths for the health checks that can do like a deep ping, checking for all the components that are required to make this API work and make sure that they all are healthy. Switching over to the updating catalog architecture, this one is very similar in the sense of we have the API gateway for our REST API, Lambda for our business logic, and DynamoDB for our storage, for our database. And in this case, we only have it in one region, though. And you can see that in US East 1. And that works well for the updating part, but we do need to get that information to the other regions too, because we have those critical browsing catalog use case as well. So we are doing replication, and we see that with the Lambda function there. And I'll go into a little bit more detail. The US 2 region has a little bit shaded icons. That's kind of to represent the browsing catalog use case. So the architectures here, the highlights here for this architecture is that single region API. Because we have multiple microservices, it does allow for graceful degradation. Even if that region that has the updating catalog microservice in it goes down, we can still do browsing. We can still do browsing and have that critical revenue service still being up. But we do need to make that replication. And this is actually fairly straightforward because we can now do this as a master replica setup, which really would simplify the replication across the regions. By having the master replica, we avoid some of the problems we have with a master setup. We don't have any sort of data conflicts that we have to worry about. There won't be a split brain scenario that we would have to deal with. And setting that replication, setting up that replication is fairly straightforward as well. And we're going to use Amazon DynamoDB streams to do that. The other thing that's great with AWS Lambda is that that's a built-in event source for Lambda. So when there are changes happening to the DynamoDB table, all of those will be captured and put into the stream. The Lambda function will be invoked. All of those changes will be put into the payload. The function can now iterate over those, connect to the table in the other region, and replay all of those updates. Right, and we have the replication working. All right, now Stefano's going to go and look at the submit order use case.
Thank you. Yes, submit order. The requirements are pretty straightforward. This is the core to our business. Your business users will come around and hit you hard on the head if this goes down, because this is our primary revenue stream. This is how we make money. We cannot afford to go down, and we need to be able to accept orders from any one customer in any region at any time. It doesn't matter whether one fails or not. It needs to be up. And so if we go through our decision tree, you can see that, yes, we need to go multi-region. It's key to our business. And we need to be able to read and write to all regions at the same time, which instinctively makes you think, oh, I'm going to get my master setup going. In fact, when your business user comes along and says, I need you to build this incredible service that never goes down and synchronizes across region, and it's just perfect. As a developer, I get pretty excited. It's a nice, chunky problem to address. And I know I'm going to go away for a while, build this beautiful baby, and then when I deploy it and try to actually operate it in production, it turns out that it's a bit of a Frankenstein. And this is where I go back to my original note, which is, as you go multi-region, there will be compromises. And Magnus and I decided to make a compromise here, which is, well, yes, you can create orders in any one region. From that moment, that region will become the master for that order. And no other region will modify that order other than that one. And that is because in the physical universe we occupy, speed of light being what it is, ACID transactions across multiple regions are just not going to be fun. It's not going to be nice to operate. So we needed to find a way around this. And the other thing that concerned us is, given that we cannot have true ACID transaction across multiple regions, we run the risk of presenting customers and users with inconsistent orders. I created in region 1 that's being replicated in region 2, but suddenly I try to read it and half the food I ordered is not there. So I add it again and then I order it twice. And we thought, this is going to turn out to be a worse customer experience than us saying you're tied to that region. If you lose that region while you're creating the order, then we're just going to say, sorry, we're going to have to start again. And this doesn't necessarily mean that it's going to be a really bad customer experience. It just means that we're going to have to make our backend pretty smart and our client also smart enough to be able to handle this use case. Presumably our client will have a state of the order and can just resend it somewhere else. As I said, eventual consistency is going to be painful, but more than anything, with this setup where we have a home region for an order and we're just going to talk to that region, we only expose ourselves to one edge case, which is where customer has created the order, has added all their items to the order, and then as they hit submit, we accept the request and the region dies. It is possible, but unlikely. And because it is an edge case, this is something we're willing to accept and deal with manually. We'll have procedures when the region comes back up to handle the case, but otherwise, everything else works. And more than anything, it works simply. The code for a software is simple. The path that the order takes to be created and processed is one. There aren't edge cases where if one is down, but I can pick it up from the other one, go somewhere else, because that's not going to be a lot of fun to operate when it actually starts happening. So as I said, this is, we're going to have to write server-side code and, well, I shouldn't say server, so it's serverless. So we're going to write our backend and our client together. so that they're smart and can act in concert to create a good experience for the end user. So the way we've designed this is that the client will send the first request to that global endpoint that Magnus described that is balanced with Route 53. Route 53 will decide, yes, this is your best region, low latency, and it's up. So go there and create the order. We'll send the instruction to the backend, and our code will create the order. Once we've created the order, what we'll send back is the order information. It's going to be an empty order, but we're going to generate an order ID for it. And the approach we've taken here is to make the order ID a little bit smarter than a plain auto-increment number. We're going to generate something similar to an ARN in AWS. And it's going to contain more information. It's going to contain, yes, a numerical identifier for the order, as well as the home region and the customer ID. And that allows our backend code to make very quick decisions in a stateless fashion without having to go off and query databases somewhere to figure out if I'm the home region or not. If I created the order in US West 2, and that's set as the master region, and then the client tries to send a request to edit the order to US East 1, US East 1 can just look at the ID that's been sent and say, can't help you there. Try again. And so that means we have to create 3 endpoints. We'll have our global API endpoint that we can address, but we'll also have region-specific aliases. Because once the order is created, the client gets back that order ID and says, OK, I am US West 2, so I'm going to go talk straight to the US West 2 endpoint anytime I need to edit the order. Now, do you want to synchronize this data across regions so it can be read from other regions? Yes, you don't necessarily have to. That's more for business intelligence application or in case somebody wants to see their order history later and somehow one region is down. And there we would use the same technique that Magnus described for the catalog, where we use DynamoDB streams to just replicate that. But no region should touch an order that doesn't belong to that region. And so at the end of all this loop, the client will just send a request to that master region to say, go ahead, I'm closing this order, go ahead and process it. If at some point during this time, the US West 2 region goes down, we lose our application there, the client still has the state of the cart for that order of the basket. And so once it receives that error, there's no edge case in our code, there's no smart if. The client will simply say, OK, I'm going to start this flow again. Send it to the global endpoint, say I want to create a new order, pick a new master region, and continues exactly as it is. And for our end user, this should be a pretty seamless experience as well, if we handle it well. So we've made a significant compromise, but ultimately, our code is simpler, it's going to be easier to operate. And as far as the end users is concerned, there shouldn't be any challenge. And we haven't taken this approach just because Magnus and I are lazy and didn't want to deal with the complexity. We actually explored quite a few possibilities. And I'm going to talk through a few of them that we discarded along the way. But we decided that this was the best compromise between user experience and our ease of development and operating the service. The other thing that I want you to note is in this final slide, once we accept the order, we have a dependency, a third-party payment processing system. And as you can see in this slide, I have 2 regions running my application, but I have only one payment processing system. And I see this a lot. You can go to as many regions as you like. If your third-party dependencies use a single region and they go down, all your work is for naught. So as you take dependencies, make sure that they're just as redundant as you are. In fact, if you decide to regionalize a service, your dependency should live in that region or in that geographical area so that you can neatly isolate it and say, this is the US East box, the US West is somewhere else. So the other options we looked at, the first one, the obvious one that anybody who set up master database or tried is pessimistic locking. Doesn't quite work. It doesn't meet our requirements for latency. As you add more regions, you're going to have to start locking in multiple regions, and all locks have to be successful. Otherwise, you go back. Too many edge cases. Too much latency, too many edge cases, not worth the effort. Quorum-based algorithms are interesting because we can go to many regions. In fact, we should have a minimum of 3 regions for a quorum-based algorithm. Latency doesn't increase as much as pessimistic locking on the right use case, but we still end up with potential inconsistency in the data across regions. All in all, probably not worth it. Read quorum is also an interesting one, but once again, latency because we need to query at least 3 regions, and data not being replicated consistently remains an issue. Too complex for what we gain from it. The last one, conflict-free replicated data type, is an interesting one. You could have, for example, a vector clock on the order record, and in your DynamoDB stream Lambda function, you could have some conflict resolution logic looking at this vector clock. Pretty straightforward to do when your data record is a counter of some sort. When you start dealing with more complex objects, it can get pretty hairy. And ultimately, if you think about customer experience, you really don't want to have a failure in that conflict resolution. Because I've placed an order with 1 cart and I suddenly found twice the amount of food delivered and twice the cost for my order. It's not going to be very good. All in all, I'd rather take the pain of losing 1 region, I got to start again. And the client makes that seamless. Hopefully that all makes sense. So to summarize, yes, it is an active-active API in the sense that we can write to any of the regions. We're making a compromise to say a master region is the only place where we can update an order. And if we lose that, need to start again. The stack remains the same. We deploy the exact same code to all regions. All of our code has a check in it that says, oh, I'm running in US West 2. You send me an order for region X. I can't handle that. And finally, if you're interested, we do replication using DynamoDB streams. As I said, it's not mandatory for this particular service. The other important point is that we made the client smart. We all have big dreams of having dumb clients and our APIs just distributes across multiple regions seamlessly. When you're talking about complex applications that have a flow in a sort of session, a workflow, like placing an order, create it, update it, add item, this becomes very complex. Your life is going to be much easier if you make the client a little bit smarter. And so this closes the order service. And now I'm going to let Magnus talk you through monitoring and logging for this application.
Thanks. So I want to touch upon some of the operational stuff. And one thing that Stefano said earlier was it's really important that we automate as much as we possibly can, right? So a really important aspect of that is monitoring. So there are many different ways to use it, but one way that we did for this is using Amazon Cloudwatch to really knit a lot of these things together. So starting by looking at what we're doing within a region itself, we're leveraging the metrics coming out of all the different AWS services that we have. So we'll get really granular metrics on how the application are performing within that particular region. But we want to add things on top of this, though. So we will use custom metrics and scheduled lambdas to now start querying for metrics across regions. And this is really important because when a region goes down, we want to be able to have those metrics available so we can actually start alarming on them and start taking actions when that happens. One thing to not forget about as well is Amazon Route 53 have all the health checks. And all the metrics that are coming out of that will be sent to the US East 1 region. And using the Cloudwatch dashboard functionality, it does allow to pull in all the different metrics from all these different regions. So you can have one place where you can see the metrics for all the different regions where you have things deployed. To kind of summarize that, really go with the granular metrics within the regions themselves to see how things are working there, more coarse-grained across the different regions so you have those metrics available. Don't forget about Amazon Route 53 global health checks, and then that single pane of glass they can get from the dashboard. We also have to think about the logs themselves. They provide us a lot of valuable information. So we really recommend to centralize the logs so you have the ability to effectively query them, and you can really see how your application is doing as a whole. And you can use that when you troubleshoot. So here we're using Amazon Cloudwatch log functionality to do the centralization, aggregation of the logs within each region. We can stream all of those log items into a Lambda function. And as those items come into the Lambda function, now we have the option to decide exactly where to put them. And I'm showing two options here on the screen. So the first one, we're putting all the items into one Kinesis Firehose stream. It will batch all of those items together and put them as objects into Amazon S3. That actually provides us an ability to directly then query them using Amazon Athena to do ad hoc queries. Another option, which is not completely serverless, but still kind of popular within the serverless community, is using Elk. So to do that option, you can use the Amazon Elasticsearch service. You can put all the log items into that cluster. And it comes with Kibana as part of the service. So now you can use that to kind of monitor all your logs and then do queries on it. The last part I wanted to touch on was the deployment. Because we really do want to put this the same thing into every region. So one key part is that we really want to put this as infrastructure as code. We really want to define our whole application in a way that we repeatedly can push this into different regions. And the thing we leverage to do this is the serverless application model. Right? So that really allows us to put all of these things as serverless as code. And then we want to put this into some sort of CI/CD tooling, and there's a lot of different options out here. Here I'm showing the ones you can build with our developer tools. So if you're doing that, you can put all the code, all the artifacts, all your SAM templates into code commit. Then use code build to build your application in combination with SAM. And then also use Qtable to test it, because we need to do all the unit tests, all the integration testing. And the output of that would be CloudFormation templates. And then we can use those along with all the artifacts, all the code packages, to push that into all the different regions. And then finally orchestrate all of that with code pipeline. I also wanted to quickly kind of show some snippets of how those templates look like. The thing that you see to the left, that's an example of a SAM template. This one happens to show the Browse Catalog API definition. Highlighted in red, the new feature that I talked about the regional endpoints. That's how you would configure those. And then we would, using that in combination with a CloudFormation template, this one is configuring the Route 53 records to do that active setup. And I'm kind of showing them both to show that in combination you can really use, in the combination of both, you can really get the full feature that you need to define your serverless application. Right, Stefano.
Thank you. Yes, and summary. Now I am the last thing standing between yourselves and beer o'clock. How many of you have used SAM before or know what SAM is, the serverless application model? Cool, excellent, a lot of hands. SAM is how we recommend you deploy applications that make use of serverless services. Not just because we like SAM, but because what we want you to think about is that you're deploying a microservice by itself. And a SAM template is not just the domain name, it's not just one Lambda function, it's your entire service. It's the API front end, it's all of its Lambda functions, and it's its dependencies. S3 buckets, DynamoDB tables. We want you to declare all of those in one template for the service, and that gets stamped out in each region exactly as it is. That's a great way to make sure that you have the one stack consistent across regions and across environments. Beta looks exactly the same as prod. And we have lots of samples on creating CI/CD pipelines for SAM. To summarize this presentation, though, I cannot stress this enough. Going multi-region is a big decision. It's not one the technical team takes by itself. It's something that you need to check on with the business side. And it will have significant impact on how you build applications and how you operate your applications. Suddenly, you're operating across time zones. I'm sure there isn't one operator here who says, yes, I want to be the 24/7 on-call for Europe and the US. You have to start automating a lot of stuff. Keep that in mind. Very often, at the same time, this can turn into a worse customer experience. As you try to build your replication, eventual consistency of the data will mean that customers may end up seeing inconsistent records. So make sure you think through this stuff, and like we did, adopt perhaps that home region trick. This way, at least I'm sure that our customers are always seeing the same consistent data. There's a lot you can do there, and there's a lot of architectural patterns. So make sure you think through that decision. And finally, Route 53, automate your load balancing of the regions with the DNS. You want to set your health checks as well as the latency-based routing. But make sure that you also have a way to address a region directly. So that if everything, absolutely everything goes wrong, you still have that one way in. If it all makes sense, I'm just going to close with the next steps. We actually published a blog post tutorial on setting up our food for thought application. It's on the AWS Compute blog. I was going to say it's going to be the latest blog post there, but with all the launches at reInvent, it's probably a few pages down now. So I will definitely give you time to take a picture of this. And take a look at the documentation for the regional endpoints in API Gateway, because that's what gives you control of your DNS record. That's what allows you to set up multi-region applications. And with that, thank you very much for coming to our sessions. We'll give you 15 minutes back. Thank you. Please. Thank you.